Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, our lesson today will actually look at construction of three-dimensional diagrams. So for the most part of our lesson, we are going to, or I'm going to get you to do some construction or drawing of three-dimensional diagrams in your exercise book. And the drawings will be actually based on the plate, three movements that plates do, and that is the convergence, divergence, and when plates slide past each other. But we'll come to that when we complete what I'd like us to look at now. Let's revise on what you have covered so far. What we have actually done together and what we have covered so far is we've looked at different tectonic plates. We found out that the Earth's crust is actually divided into different tectonic plates, of which those plates move on top of the molten layer of mantle, which is referred to as the asthenosphere. When the plates move, they carry with them the continents and the oceans. We also found out that the major plate boundaries, or the major tectonic plates, that is, they move in different directions. In some atlases, they will also give you an idea of by how much the plates are moving in a year. And some of them might be at a rate of 0.5 centimeters or millimeters per year that the plates are moving. For the 7 major plates, we looked at the general direction in which they were moving. We also looked at the fact that when plates move, they can either come together, two plates that is, can come together, and when plates come together, what we call then, that movement is referred to as convergence. Or you can also have collision of plates when two plates meet or they come together or move towards each other. Plates can also move away from each other, and when two plates move away from each other, the term we use to describing that movement is divergence. And the third movement that we looked at was when plates slide past each other, and what is usually created when plates slide past each other is a transform fault. We also looked at some features that are formed as a result of plate movements. And those features, when you do the activity that I will assign, you will need to accurately plot on your diagram those different features. So let's look at those features again. When plates converge, the main features that are created are, especially when there is an oceanic plate meeting another oceanic plate, or an oceanic plate meeting a continental plate, then what happens is that one plate is actually subducted, resulting then in the formation of a trench. A trench would usually be formed on the oceanic plate. So one of the features associated with convergence of plate is trenches. Another feature which is actually created as a result of collision or converging of plates is that of fold mountains. And we looked at an example of the Himalayas. The Himalayas has been formed as a result of the converging of the Indo-Australian plate together with the Euro-Asian plate. You also have the Andes of South America, but this time it is a continental plate meeting a oceanic plate. On the continental plate, you can expect to find a fold mountain being created. Andes of South America is a good example. Other features that can also be found when plates converge, where continental plates meet, volcanic arcs can actually be formed. And a volcanic arc is simply looking at a chain of volcanic islands that are formed as a result of converging of plates. Volcanoes are associated with plate boundaries. Where you have plate boundaries, you can expect to find volcanoes. And I also mentioned that the Pacific Ring of Fire, that's a group of volcanoes that goes right around the Pacific region, or the Pacific Rim of Fire, simply tells us that that is the edge of what we call the Pacific Plate. Volcanoes can actually tell us the boundaries of certain plates. So the features again, trenches are formed when plates converge, fold mountains are formed when plates converge, volcanoes are formed when plates converge. You can also have what we call fissures or cracks can also be formed when plates converge. And finally, where there are plate movements, you can expect earthquakes to be felt. So those 5 features again: trenches, fold mountains, volcanoes, fissures or cracks, and earthquake can be felt along areas where there is tectonic plate movements. The second movement is that of divergence, and when plates diverge, that means they're moving away from each other or they are drawn apart. And the main feature that is created as a result of that movement is the ridge, formation of ridges. Most of those ridges are actually found along the ocean floor. Therefore, they are referred to as mid-oceanic ridges. That would be the common feature which is formed for plate divergence. Also, again, when plates diverge, it's to do with tectonic movements. Therefore, volcanoes will be common. Fissures or cracks on the Earth's crust will be common, and earthquakes are also common. Finally, the third movement we looked at yesterday is that of plates sliding past each other. And when plates slide past each other, the main feature that is created is that of a transform fault. And note that because, again, we are dealing with plate movement, volcanoes and earthquakes are common. Volcanoes and earthquakes are associated with tectonic plate movements. Along the boundaries of plates, you can expect to find volcanoes. And at the same time, you can also experience earthquake where there are plate boundaries. If we go to what we have covered so far also, we looked at examples of plates that are diverging, those that are converging, and also one of the work that you were supposed to have completed was to look at plates that were sliding past each other. I'd like to make a correction, first of all, to one of the plates, or the two plates that were given yesterday, and of which I said no, it was not correct. And that is for the answer that Gideon gave on the Antarctic plate and the Pacific plate. Yesterday, I said that they are not diverging, so we will not consider that answer. Having checked through that information, and Gideon found that there is a ridge that is also found along where the boundary of the Pacific plate and the Antarctic plate is. And if it is a ridge, then obviously the plates are diverging. So his answer was definitely correct. So we could also include that with our list and make the correction to that particular question where I said it was not correct yesterday. Okay, so divergence of plates, we can see one more example. The example which was not, or the example yesterday which I said was not correct, of which I am now saying that it is correct, and that is Antarctic plate and the Pacific plate are diverging. Note, for the movement of plates and also the movement on the lithosphere, we also already found out that the main energy, which is actually used for the movement of plate, comes from the convection currents. And the convection currents within the mantle operate in such a way that they're able to actually move the lithosphere or the crust. We also looked at the different features which are actually formed as a result of those plate movements. And I have already explained them also in the introduction to the lesson. And what I would like you to do now is, in your exercise book, using a pencil, I would like you to construct a three-dimensional diagram showing each of those three movements that we have already looked at. So if you look at the first example on our screen or monitor, that movement is the movement of divergence. It's a three-dimensional diagram, that is, but the point that I'd like you to ensure you are doing correctly is that when you are plotting in the feature of where the ridge is, make sure you point exactly on your diagram that you will construct where the ridge should be found. If you look at your textbook, not the textbook, but the booklet, sorry. You look at the booklet, and you will look at the information given on figure 9. And if you look at the label given there, which is for the ridge, can you see that the ridge is actually written on the side and there is no arrow pointing to where the ridge is supposed to be? Okay, what I would like you to do is I'd like you to ensure you point accurately to your diagram where the ridge would come in, where plates diverge. And I don't want you to just write it on the side and leave it there. I want you to accurately maybe use an arrow to point where the ridge should come in, like the example given here. A three-dimensional diagram, they are showing the movement with the white arrow, and here they are showing us the ridge will be that point. If you just write ridge out here and you don't show, then I will not know or other people will not know where the ridge will be formed in this diagram. Okay, the second one, the second three-dimensional diagram you'd have to actually construct will be that of plates converging. When plates converge, I'd like you to also include those 5 features that I have already mentioned: volcanoes, trenches, fold mountains, fissures. For the earthquake, you will not be able to plot accurately where it will come in, but you can mention along the side that this area also earthquake will be common. So those 4 features, again, I'd like you to point accurately to your diagram on where they come in. And the third movement, which is of 2 plates sliding past each other, your 3-dimensional diagram, and note also where the transform fault is. I'd like you to plot accurately where that would also come in this particular plate movement. Okay, so to go back now to what you're supposed to do for the lesson, I'd like you to do a construction of each of those plate movements. Do a 3-dimensional diagram for each of those plate movements, and then accurately plot on those diagrams the features we have looked at. So the rest of the time now is going to be given to you for the completion of that work. You'll have to actually ensure that you point exactly to where the ridge is, and do the same for the trench. And the trench is not enough. That diagram is not enough. You'll have to actually put all the other features also. Okay, when you look at this feature, describing what a ridge is, to you, according to your diagram, how would you describe what you have drawn? Okay, and that's where you're going to actually get it wrong. Remember I mentioned about trenches? A lot of people think that when plates diverge, there is a trench or a gap, and that's not true. When plates diverge, there is a ridge that is formed. It's like a small hill or mountain under the oceans. So therefore, when you're constructing a diagram, it might be better to put this. So you are not looking at the gap, but you're looking at those features that are formed. You do it in such a way so this area is like a higher area, and this area also is a higher area. first one done, so you can do the other two. Convergence and also transform fault or plates sliding past each other. Okay, you see the ridge that you pointed there will not be in there. The ridge should be here, yes. And the way you show that, if you look at your diagram here, it's like a gap, but it's not supposed to be so. So your diagram should see like a small hill or mounds which are formed under the water to be referred to as the ridges. So it's this one here. You have the volcanic arc. Okay, you see, where did you put the trench? Where is the trench? Yeah, well, which is okay. This is okay as it is, but you are pointing to this point here, of which it would be clear if you pointed here instead of up there. Can you see that? It would be clear to have the trench here rather than out there. Or you could have it there. Can you see this? Or here. Okay. Okay, where is the fold mountain? Where will you put it on your diagram? Yes, okay. So that means you'll have to name those two different plates that are meeting. One continental plate and the other one will have to be an oceanic plate. And then you'll have to include also those fold mountains. Or on your diagram here, you can still have those if you maybe just simply put something like what it would look like a mountain and then indicate that a fold mountains and continental plate, oceanic plate. Where is the transform fault? Where on the diagram? Between. So that one should be between those two. You might use different arrows, different colors for your arrows. Otherwise, you get confused whether the arrows are showing plate movements or whether they are showing us displacement of rocks or whether they are showing us the features. So use the different colors to indicate the feature, a different color for the movement. You'll have to remember that for convergence, you can have a continental crust meeting another continental crust, or you can have a continental crust meeting an oceanic crust, or you can have an oceanic crust meeting an oceanic crust. For you to be able to label and put in all those features, if you wanted to, you could only construct one diagram, and that one diagram can show all those features, but making sure you must label which is which, the continental crust meeting the oceanic crust, what is formed along the ocean floor beds, and what is formed on the continental landmass. That one diagram can sum up the whole thing. Otherwise, you'll have to do two diagrams, one oceanic crust and oceanic crust on its own, and then you still do convergence, oceanic crust and continental crust. And you could do the third one, continental crust and continental crust. That's better. The feature label, where? Where is the feature? The first one. Where are you going to put it? No, you have to make sure you put it somewhere and put an arrow to indicate exactly where it is. Maybe at the top there, write the feature and then get an arrow and point exactly to where, yeah, exactly, yep. Like I said, I don't want the ridge to be written there. I want, it's okay, I want you to get an arrow and you point exactly to where the ridge is on the diagram. You see, if someone picks up this diagram, they'll say, okay, ridge. So they might be wondering, it could be here, it could be there, where is it? So we want you to be able to plot accurately where it falls in and it comes in. The fold mountains and all that, where will you put it? You see, for this one, it doesn't show you the fold mountains. What do you think these ones are showing? No, they are not only mountains. Check again, check that information again. You see. This thing here is coming out from that, so it has to be. Yeah. And if a line of volcanoes, then what would they form? Volcanic arc. Okay, so that means these are all the island chain of volcanoes. Volcanic arc, that is. Fold mountains, where will they come in? Cracks or fissures? How do you show that on your diagram? Good, that's what I wanted, yep, right there to show the ridge. Okay, the trench. This is the already under the surface. If you're looking at the surface, so you got to point it up here to the top there. Yeah. This then is already the next layer, or the area not on the surface but under the surface. So you got to point to the features on the surface. Unless you are referring to this section here, what do you think this is? This zone here. What has actually happened here? One rock has, or the layer has gone under the other. What is the process referred to as? What happens when a continental plate meets an oceanic plate? Yes, subduction, okay. So this zone here, or area here, is the subduction zone. So therefore at the top there, you put the trench. Okay, so if you check on your diagrams, see the first example on the monitor? That's exactly what I mentioned I'd like you to do. Make sure you point to the feature. Also, a lot of you have different arrows which are actually on your feature. Perhaps put one color to show the plate movement, and then use another color pen to show the features. Some of you might use red, and all of it is red, and then you're not sure what those red pen are showing. So perhaps the red pen that you have, if you already have used it, you can use it for plate movement, direction of plates, and then use another pen, maybe blue pen or black pen, to indicate the features. Okay, so if you had done your diagram, this is what you should have. Plate moving away, exactly where the feature is I'd like you to plot. Okay. Make reference to the second information on the monitor and your text or exercise book, and double check also that you have correctly labeled the features. Usually, which one? On this one? Okay, when you look at that particular diagram, it is saying it is an oceanic crust under an oceanic crust. So that means those two plates are of oceanic lithosphere. So that means the fold mountains, you will not expect to find them there. Unless it is a continental meeting a oceanic, or continental meeting a continental, you're correct. That's when you have the fold mountain. So this is oceanic crust under another oceanic crust. Let me see, where is your diagram? Can I have a look at your diagram? Okay, the second one you need to put in is. Okay, that's it. Good. So you have oceanic plate, continental, the fold mountains are here. Volcanic arcs can be actually along here. The trench is there. This part here, what is that referred to as the zone here? Subduction zone, exactly. You label that in. The process of subduction has actually taken place. And then you can also include the cracks or the fissures. You see, the cracks or the fissures should be easy. Exactly. For this one here, what is happening is they're coming up, and the magma is coming up and to those volcanic arcs. But you could also just, have a gap in the whatever here. That's it. That gap there could indicate a crack of which magma can flow out through, or even along here. And then you can label cracks or fissures if you complete your diagrams. And that should be like, so there you go. I mean, you can do that a little bit neater than what I've put up. Okay. Incomplete simply because you've only got a trench. Where the fold mountains, what happens to the trenches, where is, the volcanic arc, you haven't labeled, even though, you see, it's the island of volcanoes. You haven't labeled the subduction, you haven't labeled which is a continental crust and which is oceanic, or are they both oceanic? So this is incomplete, so I'd like you to, maybe what you could do is you could extend a little bit out this way so that you can also include the fold mountains and the other features on the same diagram. See, like what he's done there. Show what you have done. He's got only one diagram, and see, continental meeting an oceanic, fold mountains, the volcanic arcs there, cracks and fissures, trench, etc. Okay, class, we'll also stop here, and I'll ask you to actually ensure that you complete those diagrams for your homework. Before we finish off, we double check again to make sure you are going to do the right thing. Number one, you were supposed to construct a three-dimensional diagram. I also mentioned that when you are plotting in those features that we've looked at, which are created as a result of plate movement, it is important that you accurately plot on your diagram where those features are actually found. You can construct, for the converging of plates, you can construct 2 or 3 diagrams, or even 1 diagram to show all those features. We'll take, for example, if you are going to show the fold mountains, the trenches, the volcanic arcs, the fissures or the cracks, you can have a continental plate meeting with an oceanic plate. The continental plate, oceanic plate. Oceanic plate subducts, a trench is actually formed. Still along the oceanic plate or lithosphere, volcanic arcs can actually be formed. Cracks and fissures can also be formed. On the continental plate, you now have volcanoes that can actually be created, cracks or fissures created, and at the same time, you also have the buckling of the Earth's crust giving the fold mountains. So that one diagram including all those features. Or if you were thinking of doing the separate features, converging, oceanic crust meeting another oceanic crust, the volcanic island arc being formed, we have fissures or cracks being formed, a trench being formed, and also here the process of subduction where one of the weaker plate is actually forced under the other. But this is oceanic crust under an oceanic crust. This one, oceanic crust meeting an continental crust, still convergence. And then for the transform, ensure again that you accurately plot in where the fault is. So what I'd like you to do for your homework is to ensure you complete your diagrams and have them well labeled before our lesson next week. That will also bring us to the end of the lesson. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 24 is ocean ridge. Good afternoon and thank you, students.